The second part of today's notes, this is part 2, will be the intro to Notes 10.1, 10.2 worksheet. So first of all, let's talk about a central angle. The definition of a central angle is an angle of a circle is an angle with a vertex in the center of the circle. So here's the center, okay, and then therefore this would be my central angle. And we would name it using the center as O. So we'd say angle AOB is the central angle. Okay. Make note here that the central angle is the same measure, an underlined measure, as arc AB. So that means it's measured in degrees. Okay. So arc is our next definition. But if I highlight this in red, this is arc AB. Okay. So what is an arc? All right, an arc is a part of the circle defined by two endpoints. The arc length is what we call a portion of the circumference, a portion of the circumference measured in linear units. So when we get to arc length, the linear units will not be in degrees. So not degrees. Excuse me. So let's look at some of the arcs that are in this picture here. So arc CI would be an arc. So we'll put arc examples. So CI, and our notation includes the little arc the way I drew it up here also. Now if we have a large arc, we can name it with 3 different points, but they have to be in order. So for example, we could have CIR because it goes from C to I to R. So CIR would be in order. So order here matters. All right, let's write a couple more examples. We have Let's look at LR. We have arc LR. We also have, let's see, we could look at LCR. Let's do, yeah, LCR. And let's do one more. Let's do LC. Okay. Now arc length has a formula. Oops, TH. There we go, arc length. And that is L for length is equal to 2 pi r m over 360. So this arc length equation we won't use too much until later units, but just so you know that it has a specific equation, arc length is different from the measurement of an arc. All right, let's take a look at major arc and minor arc. So a major arc, we'll put arc here, is an arc that measures more than 180 degrees, but less than 360. Okay. A minor arc is an arc that measures 180 degrees, or less than 180 degrees. Oops. Measures less than 180 degrees. So in this picture, a minor arc would be AB. So arc AB. A major arc would be something like AQB. So a major arc has to have 3 points in the name. A minor arc would only have 2 points in the name. All right, a semicircle is an arc that measures exactly 180 degrees. So here, this would be my semicircle, and my arc would be ABC. And an arc that is a semicircle can have 3 points in the name. So here we have ABC. My arc would be ABC. Make a note that it has 3 points in the name. Okay. Now my next theorem, 10.1, talks about congruent arcs. Right? So in the same circle, or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So like I mentioned at the very beginning, so let me go back to the very beginning here real quick. The central angle is the same measure as an arc AB. So here's my central angle, here's arc AB, they are congruent. If I have congruent arcs, that means their central angles are congruent. So for congruent arcs, let's write down arcs in the same or congruent circles that have the same measure. So for example, in this picture here, if I know that angle 1 is congruent to angle 2, then the arc FG is congruent to HJ. Now vice versa. If I am given first that these arcs are congruent, then their central angles are congruent. So here we have the converse. That's why we used an if and only if in the definition of this theorem. Now we have a couple more things here at the bottom of the notes. We have arc addition postulate. It says the measure of an arc formed by two adjacent arcs. So remember adjacent means next to. Okay, so the measure of an arc is formed by two adjacent arcs is the sum of the measures. Now I'm going to make sure we put measures of the two arcs. So just kind of refresh. We had segment addition postulate, we've had angle addition postulate, now we have arc addition postulate. There should be notes there. So for example, in this circle D, and that tells me that this is my center, measure of arc AB is 45 degrees, and the measure of arc BC is 152 degrees. Find the measure of ABC, arc ABC. So all I really have to do is look at my angle addition postulate. These are adjacent arcs, so I'm allowed to add them. So 45 plus 152 is 197. So the measure of arc ABC equals 197 degrees. So measurement, we're talking about degrees. Now in circles we'll talk about radians, like pi radians. We're going to change this to, instead of radians to degrees, we're going to say radians from degrees. And same thing here, let's change this degrees from radians. So if I want to change my degrees to radians, I'm going to use this formula where I'll take the number of degrees and multiply it by pi over 180. But let's say I have pi radians first and I want degrees, so I will multiply by the reciprocal of that, 180 over pi. Right. Let's look at a few examples. So if you turn over to the page on the back, and let's look at radians to degrees and degrees to radians. So first it says express 45 degrees in radians, right? So I know I have 45 degrees. I want my answer in radians. So that means I'm multiplying by pi over 180 degrees. And I'm going to multiply by 45 degrees. I'm going to write that over 1. And when we multiply fractions, we multiply straight across. So 45 degrees pi over 180 degrees. Now, I want my answer in pi radians. So I'm going to end up having to reduce my fraction. So 45 over 180 is 1 over 4. So I have pi over 4 radians. And I'm going to abbreviate radians with RAD. For the next one, it says express pi over 2 in that's currently in radians, 2 degrees. So then remember I said let's take the reciprocal if I want my answer in degrees. So 180 over pi times pi over 2. And this is the reason, because when I multiply straight across, I notice that I have a pi in my numerator and denominator. They're going to cancel out to 1. And I'm left with 180 over 2, which is 90 degrees. All right, let's try one more. So let's express 5 pi over 6 in degrees. So I know I want my answer to be in degrees, so I take 180 over pi and multiply by 5 pi over 6. And again, you should notice that your pi's will cancel out to 1. And I can kind of reduce some things here. I know 6 goes into 180 30 times. 6 goes into 6 once. So when I multiply straight across, I have 30 times 5 and over 1. And 30 times 5 is 150. So my answer is 150 degrees. All right, let's take a look at my second example. Now we're looking at angle measurements and arc measurements for these next couple examples. So first one, it says, in circle C, find each of the following. So the first part will be find the measure of arc AB. So if I want to find the measure of arc AB, that is 60 degrees, because that's the same as the central angle. Okay, so same as central angle. Now to find the measure of ADB, now order matters, so I can't go ABD, it has to be ADB. So I start here, AD to B. Okay. Well, a whole circle is 360 degrees. So I'm going to take 360 minus 60, and that's 300 degrees. Okay. All right, last but not least, part C, we have find the measure of DB. All right, and notice here that we have a diameter which creates a semicircle. So ABD, arc ABD, is a semicircle. And I'm going to use that because a semicircle is exactly 180 degrees. So I'm going to take 180 minus 60, and I get 120 degrees. All right, in step 3, or not step 3, question 3, we have circle P, all right, and it's really important that if we are using circle P, that it's defined as the center. Okay, Okay, and just by saying the circle P, that means P is the center. Okay, all right, so find TSQ as our first one. So I start with T and go all the way to S, and then the next one would be Q, so that's my order. All right, well, here's a semicircle in this arc, and I'm going to add that to 80. So 180 plus 80 is 260. All right, let's look at US. Right, to find the measure of US, I'm going to use the arc addition postulate where we have 25 plus 80. And I'm left with 105 degrees. Okay. All right, find the measure of arc RU. So that's going to be this guy. And I know it's this one, excuse me, as opposed to RU, because it's a minor arc. So remember, a minor arc is only measured with two, or named with two endpoints. So I'm going to take 180, because this is part of a semicircle here, minus 25. And I know it's 155 degrees. Okay. All right, so large note here. Earlier we talked about P being the center. So as long as P is defined as center, then we can use vertical angles. So notice here that I have a pair of vertical angles. So if I know this is 80, this is also 80 degrees. Now let's find the measure excuse me, of TSR. And it's a semicircle, so it's 180 degrees. All right, sorry, I had to get some water there. Okay. Question 6. Name two congruent arcs. Well, we can do that by looking at our vertical angles. So I have arc QR, or RQ, is congruent to arc TS. All right, so step 4, I keep saying step. Question 4 is an important one. But there's something missing that didn't print out. So it says write 3 different equations that would solve for x, and then choose one to solve. All right, so let's look at this circle here. Let's write the 3 different equations. Again, I'm going to reiterate that as long as we know F is defined as the center, which it says given circle F, that means we can use vertical angles. So I'm going to set these 2 equations equal to each other. 2x plus 28 is equal to 4x minus 7. And let's go ahead and solve this one. So if I subtract 2x from both sides, I get 28 is equal to 2x minus 7. Add 7, I get 35 is equal to 2x. divided by 2, x is equal to 17.5 degrees. Okay, then let's check out our other examples in our picture here. I see a semicircle here from B to E. So if I can use that semicircle, I know it equals 180 degrees. So I'm going to take 8x minus 23 plus the 4x minus 7 and set it equal to 180 degrees and solve for x this way. Okay, so that's option 2. Okay, or we have option number 3, which means I have another semicircle on here, which is from here to here. So I can use semicircle ABC. Okay, where I'll take 8x minus 23 plus 2x plus 28 and set that equal to 180. Okay. And for practice, you can solve for all of them. They will all equal 17.5 degrees. Okay. The last page attached to your notes is the homework, so make sure you do 10.1 and 10.2 homework worksheet.